Now we come into equilateral glass prism. In equilateral glass prism, what we have is each and every angle here is 60 degree. You know, it's equilateral glass prism. So here, when an incident ray comes like this, it's a normal incidence again. You know, upon normal incidence, this will pass undeviated, okay? And passing undeviated means this again will be 90 degree. This is 60 degree. So obviously, this angle has to be 30 degree. Since sum of the internal angles of a triangle is 180 degree, okay? Now, at this point of incidence, you draw a normal. As soon as you draw the normal, this angle of incidence at this surface becomes 60 degree. Again, you know, from glass to air, the ray of light, when it is trying to come out of this refracting surface, it is moving from denser to rarer medium, and in the denser medium, the angle of incidence is 60 degree. Again, 60 degree is greater than obviously 42 degree. This 42 degree is the critical angle, and since such thing happens, we have again a total internal reflection. That is, here the angle of reflection again is 60 degree, because total internal reflection also obeys the ordinary laws of reflection. So what you have is the ray of light bounces back, suffering total internal reflection. If this is 60 degree, this is 30 degree, obviously. This is 60 degree. So what happens here? It is again 90 degree. So here on this surface, the ray of light is incident normally and hence passes out undeviated. So this is the path of the ray while it passes through an equilateral glass prism. Again, here also you have to mention all the angles of refraction, all the angles of incidence and reflection in case of the total internal reflection. I hope this was of help, and further we are going to discuss some more ray diagram problems that will be of immense